Welcome to another tutorial on MATLAB. In this particular tutorial series, we are looking into the concept of MAAB guideline, and in this particular video, we are looking into the concept of Simulink related to the MAAB guideline. In the previous tutorials, we have seen the diagram appearance in signal related to signals, how you should arrange signals or how you should give names to the signals. In the last two videos, we have seen the block uses. In this particular tutorial, we will be seeing Simulink patterns. So what are the different patterns available to do the basic operations in Simulink? So those we will be discussing now. So this is all related to the MAAB guideline. So let's get started. So coming to the Simulink, for the Simulink patterns, so we have two options when we deal with any conditional operation. So either you can use a switch or you can use a if else and then statement. So this is related to that, where you should use switch statement or manual switch blocks. So if your logic is very simple, like the input are some signals values and your manipulation is some constant value. In that case, you can directly implement switch statement, which is also reliable to use. But suppose if the criticality of the logical operation increases, in that case, you better not to use a switch block, but you should use if then else block. Why if then else block? Because this makes the complexity more simpler. And if you see over here, suppose you have a signal that is coming as an input to the if then else block, you will have either a true part or you have a false part, or the if statement true or else part. If this is getting triggered, then your first subsystem getting triggered and you will be doing a critical operation or you will be doing a bigger calculation. If the false part is getting activated, then you will be doing some another calculation, and both of these will be merged together and you will get a final calculation based on operation that you have. So in this case, the logical implementation is very complex. So that is how you should use, like that is where you should use the if then else. But if the logic is very simple, you do not need such a complex design. You better use a switch statement. So manual switch you can use, you can do the op. So this is related to the logical operations. And along with that, if you want to use the switch statement, so this switch statement, if you want to use, then you can use it till 3 levels. So the level 1, you will be using one switch and the output will be going to the another switch, and the next switch will be the output of the switch that you have. So this is how you can implement switch statement in the multiple level. So this is level 1, this is level 2, and this is level 3 of the switch. But if it is going beyond these 3 levels, then better use a if then else statement, and that is followed by the MAAB guideline. Now coming to the determination of design patterns related to the maximum value of a signal, minimum value of a signal, and if there is a signal change, then how you should design all these blocks. If you want to determine the maximum value, then how it is working. If you have a signal that has a value of 10 and it then changes to 12, then the maximum value will be the value of 12 all the time, even if the signal changes back again to 10. So this is how it is happening. So if the value is changed to 12, then next time when it is becoming 10, the maximum value itself is 12. So that is how it should be, and you will get the maximum value as 12. Same applies for the minimum value. Suppose you have to determine the minimum value. Then in that case, suppose the initial value of the signal is 10 and now it got changed to 12. Then in this case, the initial signal, suppose over here is 10. Then after the delay happened, then in the next sample time, this is 10 and this is 12. So in this case, it will determine it as 10 and you will get output as 10. In the next sample time also, if the value is changed to 8, the value got over here 8, and the 10 and 8 will be checked and the value will get updated, and you will get 8 in the next minimum. So whenever the signal value is changing, the minimum value will be taken over here, and this is the most reliable design for determining the minimum value. So coming to the determination of change, so in this case, the signal value, if it is changed, then it will be detected, and whenever there is a change, the output will be logical 1, as this is a compare block, and you will get a compare out. Suppose at the sample time 1, this value is 10, and your initial value for this signal is 0, so you will have no input change. So now suppose the value is 10 again in the next sample time, so that is no change, so this will be 0. Suppose the value got changed now from 10 to 12, now there is a difference, and this value will become 1. So at that moment you will be able to determine there is a change in the signal, and you will act accordingly. So this is the reliable pattern for designing or differentiating change in a Simulink model. Next is the initialization part. So you can do the initialization for any signal in this way, and it will be more reliable. Coming to the direction of subsystems. So these are the design patterns till this point. So if you see over here, so suppose you have a subsystem A and you have a subsystem B, then in this case, your subsystem should be organized in a unidirectional way. You cannot place the subsystem like this. So this is subsystem A, and this is subsystem B, and you cannot give the arrows like this and then the arrow like this. So this is not a guideline followed modeling. So in this case, it is violating the MAAB guideline. In this case, what is actually being said is, suppose you have a subsystem over here, whatever the next subsystem that should be ahead of the current subsystem as it is receiving the input, and then from this subsystem you can take the output and put over here. So that should be design of subsystem in a unidirectional way, and the directions should be fixed. Even if you compute any signal as a feedback, it is a good practice to have a subsystem with proper directions, so that it will be more easy to trace from which subsystem the signal is going which direction. So this is just for determining the directions of the signals and easy visibility of the signals in a subsystem perspective. If you see over here, the signal is coming out from this subsystem and going inside the subsystem, and then from here it is coming back again. So there is a good traceability over here, and that is how it should be designed. So these are all related to Simulink patterns, and in the next tutorials we will be seeing similar things related to the Stateflow chart. This is all about the Simulink design. So in this particular tutorial, we have seen diagram appearance, signals and block uses, and design pattern in the Simulink chapter, which is the chapter 6 for the MAAB guideline. So this is all about the chapter Simulink. In case you are liking the channel, please consider subscribing. In case you have any comment or query, please let us know in the comment section. We will be more than happy to clarify all your doubts relevant to the MAAB guideline. So stay connected and have a great day ahead. Thank you. Happy learning MATLAB.